Hey, how's it going? And today I'm going to be talking about quantum computing. What is quantum computing? Quantum computing is a type of computing technology that leverages the principles of quantum mechanics to perform certain types of calculations significantly faster than classical computers. While classical computers use the bits as a fundamental units of information, which can represent either 0 or 1. Quantum computers use qubits, quantum bits, which can exist in multiple states simultaneously due to phenomenon known as superposition. This property allows quantum computers to explore many possible solutions to problems in parallel. Key principles and concepts of quantum computing include superposition. Qubits can exist in superpositions of states, meaning they can represent both 0 and 1 at the same time. This probably enables quantum this property enables quantum computers to perform calculations on many possible in bits simultaneously, potentially speeding up certain algorithms. Entanglement. Qubits can become entangled, meaning that the state of one qubit is dependent on the state of another, even if they are physically separate. This property can be harnessed for various quantum algorithms and quantum communication protocols. Quantum gates. Computations are performed using quantum gates, which are the quantum analogs of classical logic gates. Quantum gate manipulates qubit states to perform calculations. Quantum interference. Computers exploit interference effects to amplify the likelihood of obtaining the correct answer and reduce the likelihood of incorrect answers when solving problems. Quantum computing has potential to revolutionize various fields, including cryptography, by breaking some classical encryption algorithms and enabling more secure quantum-resistant cryptography. Optimization, solving complex optimization problems more effectively. Drug discovery, simulating molecular interactions, and material science, discovering new material with desired properties. It's important to note that quantum computing shows great promise. Particularly, large-scale quantum computers are still in experimental and development stages. Researchers are working on building more stable and error-corrected quantum systems to make quantum computing a reality for a broader range of applications. As of today, there are still work in progress. Since this week we are on the topic of overall data, worth mentioning that quantum computing has the potential to break many of the current encryption schemes and data protection mechanisms that rely on the hardness of certain mechanical problems for security. This is primarily due to quantum algorithms called Short's algorithm, which can effectively factor large numbers and solve the discrete uh, logarithm problems. These two mechanical problems are the core of several widely used encryption methods, including RSA and ESCC encryption. Overall, my personal understanding is just that what we are talking about really over here, it's about really fast and many times faster computing principles that potentially would go online in the near future. Time frame is about 5 years, where when potentially overall technology will improve so fast that where before certain codes in terms of running those codes would be check those codes against them, and they would need to do certain computation with the 16 times 16, and how fast that process can happen now, potentially where in the future we're having different computation power technology of those codes, or potentially where before then. That's just an example, but overall, where before it was very hard for computers to do those this kind of computation very fast to check all the possibilities for 16 times 16 and finding the right fit. Overall, if the code was structured that kind of way, where would only computation would be required, that's potentially most of the data encryption and overall process would be breaking down using those cryptography overall would be broken down within the near future, would be about 5 years. Either way, everything, I guess, a mindset, everything what yourself you are sharing online, potentially it's for everyone to see in the first place. That's my own understanding. If it's up there, if it's online, if it's on your phone, potentially it's just a matter of time that it's going to be broken down and someone would find out whatever you have there. That overall is perhaps worth mentioning. That's my own understanding. I'm not a professional. I'm trying to understand this kind of area myself, and I do have some understanding when it comes to superposition and perhaps a potential way of resolving this kind of issue where it would require only computations, very large technology computation to resolve an issue in encryption code, and perhaps potential ways of resolving that. I have done some research on that, but overall, on today's topic, data protection, I personally believe whatever is up there, it would be just a matter of time. Hopefully not, but that's my own understanding. Breaking existing encryption. Quantum computers, once sufficiently powered, could quickly factor large numbers and solve the discrete algorithm problems. As a result, they could decrypt data that is currently considered secure using classical encryption methods. This will render data encrypted with RSA and ESS vulnerabilities. Secure communication. Current secure communication protocols such as SSL, TLS used in web browsers rely on public key cryptography, which could be compromised by quantum computers. This means that encrypted communications could be interrupted and decrypted in quantum computers become sufficient and advised. In other words, I understand this area very well. That would be that padlock symbol next to your browser. That's something that's called SSL certificate, and that means that all information that you're sharing with an user, before you can share it, it will be encrypted, and yourself would have a code, and other party would have a code, and the process overall is called handshake, where they're exchanging code, and using that code they can very easily decrypt that code. That's how, to some extent, simplify the process of SSL certificate and how it works right now. But potentially with those supercomputers going online, all the process will be decrypted, or whatever information you are sharing online. Data at rest. Data encrypted with current encryption standards, where it's stored on disk or in the cloud, could be decrypted in a quantum adversary gains access to the encrypted data and has the computational power to break the encryption. I have published a journal. In the journal, I'm sharing a lot of information about how to structure your time over all day, 24 hours of the day, and make most of those 24 hours. In the journal, I'm sharing key areas which I believe are ones to begin with, when organizing your day and overall structuring your day, how you should start your day, as well as how you should finish your day, as well as everything in between. That would be areas like finance, understanding finance, hydration, that would be your personal development as well as professional development, all the key areas, as well as perhaps starting with the areas like motivation. Well, I believe I covered all the areas in this journal, and you can find this journal in this video's description. If you would go to the link, it would lead you to company's website where you can purchase this journal, as well as the top retailers has as well. Thank you. Overall, when it comes to quantum computing, organizations and institutions are advised to start planning for post-quantum transition by assessing their current encryption practices and considerations, the adoption of quantum-resistant encryption methods. However, it's essential to note that the timeline for the development of practical quantum computers' capabilities of breaking current encryption standards is uncertain. It could be a year or even a decade before quantum computers with the level of capacity becomes reality. Nevertheless, the potential impact of data protection underscores the importance of staying informed about development in the field of quantum computing and encryption. There's a lot of finance right now, overall, my personal understanding in the area, to develop a lot of quantum computers and overall network of quantum computers. So there are projects up there for anyone who is interested in this kind of space. Feel free to reach out to me. I would be able to work with you in developing perhaps infrastructure of quantum computing and how quantum computing can solve a lot of problems when it comes to data processing. Thanks for watching and see you next one.